Ooh. So how many people here have programmed in Ruby or at least is familiar with Rails as well? How many people know about sprockets? Use sprockets? If you use Rails Asset Pipeline, you use sprockets. How many people like Rails Asset Pipeline? Okay, this is going to be a really short talk for 2 people. Gears is sprockets for Python. Okay? I found this about 3 months ago on GitHub. I was looking for a better way to handle assets because I do a lot of JavaScript programming and CoffeeScript, and I like less a lot. So I use less for all my CSS, and Django doesn't really handle that well. There's Django Haml, there's Django less, there's Django CoffeeScript that you can plug things in, but trying to combine those things together is troublesome. So Gears does this. It does it really elegantly, and I'm going to kind of give you a brief tutorial of how it works and how I'm using it in my project, speakerbar.com. See what I did there? Okay, so the way it works is you declare a manifest file. In a manifest file, you add these require statements. And these are, you'll notice there's no extension on these files. Because Gears looks at the extension to figure out how to compile it and what to compile it to. So if it's got a JS extension onto it, that's just plain JavaScript. I'll just handle that on to the browser. But if it's written in CoffeeScript, let me compile it to JavaScript, and then I'll pass that on to the browser. You can actually chain them together. So I might have a handlebars template that has some CoffeeScript written in it that may also have some less in it. So I will name that my template.hbs.js.coffee.less. It'll compile less to CSS, and it'll compile CoffeeScript to JS, and then it will pass that on to the browser. It's magic, and it's awesome. So let me open up Vim here. Oh, fail. That is not looking good. All right. I have 3 minutes, and I'm actually way okay on time, so. Yes. Awesome. I have a mic stand.
I knew I was good for something.
All right, let me change this color scheme real quick so you can see this a little bit better. What did I find? Was it slate? I can't remember what it was. Color? Elf Lord is really good. Yeah, there we go. Elf Lord. So let me open up my assets directory. You notice I have an assets directory now. I don't have a static directory. This is because the way that I have configured Gears, it'll look at the assets directory, and when I do a deployment, or actually if I'm running a development server, it knows to look there to get my information. But if I do deployment, I can run manage.py collect assets, and it'll compile them, compress them, put them in the static directory, and everything's good to go. So here is a basic file. It's a JS file. It requires one CoffeeScript file called core. It'll compile that core into a JavaScript file. And now I'm behind on time. I don't like this. Here's my style file, right? I require those files in. Let me open up the config, show you the settings file, show you how easy it is to configure. Let me do this. So here I set where I want the files to be compiled to. Here I'm setting where it can find the files. Here I'm defining my compilers. So there are actually backends already written for Gears. And Gears works with Flask too. So if you're using Flask, you can use Gears. So there's a less backend, a CoffeeScript backend, a stylus backend, a handlebars backend, and a Django import tool for it. So I define my compilers, then I define where it can find the assets and the name of the manifest files. So I have style CSS, I have a vendor directory saying where my vendor assets are stored. So that's it for basic integration. It's a 3-month-old project. It's by 3 guys out in like Ukraine somewhere. Contribute to it. It has really bad documentation. I am sorry to tell you that. It's only 3 months old, but it is awesome. And if you ever struggle with assets and static files with Django or any of your projects, check out Gears.
All right. Hi, my name is Ron DPplain, and I want to show you how you can use Werkzeug's interactive debugger in any web project. In particular, I was very interested in the Flask project and in Werkzeug. I made some contributions there. And when I went off to work with other tools in Python, I really missed the debugger. So here we have Tornado's default behavior when you get an exception in debug mode. And you can turn that into this. Yes, this is Tornado, and this is Werkzeug's debugger. And you'll notice it even says, your Tornado application. What a feature. All right. So, I mean, here's the basic premise. You get the idea. And I can show you a demo, because I'm cool like that, and I like to do live demos, assuming I can figure out my keyboard. All right. So this is I just clicked on view source, and it shows the source in line. I can go up here in any of the stack frames, and I can execute some code. And there's a little nice dump, and we see that it's hitting in Tornado web. And here I can see that self is broken handler. So already I've learned something about what Tornado is doing. Because you're not just looking at where the exception happened, you're looking at the entire stack frame. You can go up the stack frame and try things out. So this kind of interactive debugging is really quite something. So I have a console here, and I can import this, right? Why not? And I can even start poking at this. And this is something that the Werkzeug and Flash developers love so much that instead of using a normal debugger or print statements, we just divide by 0. And that lets us just drop right into here. And we get to see and I'm serious, this is something we love so much that we just divide by 0. And I even noticed, like, if I import this, there's some weird code in here, and apparently import this has a ROT13 implementation inside the module. FYI. So, okay. Let's go back to my slides. And how it works is that Python itself gives you all the introspection power you need against your tracebacks. It's right here in sys. So check the docs. It's really easy to use. And if you read the Werkzeug code, you'll see it. And then all it's doing is this. It's just using eval. And it's just keeping the stack frames that we just pulled off, that we've just introspected. And how you can drop it into your project is easier than hooking up a MacBook to a projector. You pull out the debugged application, and you look at this. Tornado has a WSGI container, so why not? So of course, this is only going to work for your synchronous code. It's going to get a little bit weird with async code. It's going to get a little bit weird if you're not yielding HTML pages. But if this is what you're doing, you can actually just kind of hook this up, and you can see what's going on. You can inspect your code. It's great for debugging. Don't do it in production. However, it does have a security feature in it, just so that there is a secret cookie in it to avoid anyone just sending you image tags to run arbitrary code in your machine. So we thought through those kind of things. That's good. The code is here. I'm gonna put these notes up there as well. So gist.com, or I'm sorry, GitHub gist. My name's Ron DuPlain, so R DuPlain. And I know I could use a short code, but whatever. So an idea here would be that we're thinking about is, for post-mortem analysis, we're considering serializing our tracebacks that happen in production and dumping them into some data store or database file, doesn't matter, and building an exception viewer. We would just drop anything that has like a database connection object or anything. So if it doesn't pickle, we just drop it. That's one idea that you can use. And another idea would be to actually drop it into IPython Notebook. So because this is the traceback I got when I was trying to do reveal for my Python Notebook, and I had no idea what to do with it. So let me just show you a little bit of code in my remaining time. And that is here that Tornado has a hook for get debugger HTML. And you can use that hook then to render the error page. And then when we go down into the actual application code, debug application is here. And you see that I'm just keeping a WSGI application around, and whenever there's a call to the debugger code, it just, instead of yielding what Tornado request handler is going to give you, it's just going to call the WSGI application and show you the interactive debugger. So we just completely reused Werkzeug's interactive debugger in a non-WSGI project. How cool is that?
Great job. Go Linux.
Of eye contact. Okay, no, that's fine. No, it's fine. My name's Chad. Hi, I'm Chad. golly, I'm like way behind. I want to. And all right, I realized recently that I hate giving talks, so I'm going to try. This is an experiment. This is an AMA. So I'm Chad. I run a website called Get It. And ask me anything. Go. What is Get It? What is Get It? Get It is a website where you can give money every week to people and teams that you love and are inspired by and believe in.
How much money did you give last week?
How much money did GitHub as a whole give last week? We had, I think, about 800-some people. 850 people gave about $4,500 last week to other people. Why is it GitHub and not GitTip? Because certain people that I presented the word to that had no idea what Git was saw it and were like, GitHub? And I was like, okay, GitHub. So it's not just for people who know what Git is. Yeah. Well, it depends on whether you're paying in or paying out, right? And actually, so paying in, it's 2.9% plus 30 cents. And withdrawing money is 25 cents, although we can actually drop that because our payment processor Balance, we were on Balance before it was cool to be unbalanced. And so they're actually not charging us for payout, so we can drop that. Here. Will. It's a Django app? Next question. Sorry. Quentin. Heck yeah, it's an Aspen IO app. Yes, Aspen Web Framework. Who else? How are we doing? 3 minutes. Ask me anything. Come on, these are easy questions. Somebody's got something. When are we going to run it on Node? Yeah. Next question. Here. Gawker, that was so fun. That was awesome. Yeah, okay, so this was fun. We had this incident a month or two ago where I had an interview lined up with TechCrunch, which some of you may have heard of, and I turned down the interview because they weren't willing to do the interview as a live-streamed Google Hangout. And I was like, well, never mind. I only want to do live-streamed Google Hangouts because part of what I'm doing with GitHub, what we're doing with GitHub is trying to run the whole thing, the whole company, as openly and transparently as possible, applying open source principles to the whole entire company. So I was like, journalists, like if you want to talk to me, that's cool. Let's do it live stream so everybody can see what we talk about and benefit from it, right? And so TechCrunch wasn't down with that. They were like, sure, dude, whatever. A week later, I had done 5 interviews, and we were on Mashable and some other places. So it turned out to be good press anyway. Next. So did I answer your question, though? The question was, yeah. So for journalists, yes, only doing open interviews, and everything else we try and do as publicly as possible. Bessie. Oh, my goodness, how can you help? I don't have a link. We have a new page that we just launched, github.com/for/contributors. That is the starting point if you want to help with GitHub. The 3 main things you can do to help are tell other people about GitHub. Well, the first thing is to use it. Okay? First thing is to use GitHub. Find somebody that you're inspired by. You don't have to find them. Like, you're inspired by them. So find somebody you're inspired by. Give them money on GitHub. That's number 1. Number 2 is tell other people on the internet about GitHub and in person. Number 3 is support people who are trying to use GitHub. Bessie and I were looking at this today, how to do that. And the 4th thing is to help us build GitHub and give pull requests. So /for/contributors is the starting point for that. Kenneth. The ultimate, heavens, to Murgatroyd. To redeem the economy. That's the ultimate goal of GitHub, if we can. I don't know. We'll get there. Yeah. Between GitHub and Flatter, Flatter is not funded on Flatter. GitHub is funded on GitHub. Stick that one in the pot and boil it. 30 seconds. Sorry, what? Oh, well, you can also tip anybody on Twitter or on Bitbucket, and we're adding Facebook, etc. as time goes on, as you visit 4 contributors and give us some pull requests. 12 seconds. Here. Usually like a half cup in the afternoons, maybe twice a week. Thank you.
Okay, so this is not quite Python programming. This is a little lower level, but it's two clever uses of an operation that many of us have forgotten about. XOR! Binary XOR specifically. This is a wonderful operation. You can do a lot of really clever things with it. Here are two of them. First, a quick refresher on binary XOR. If you XOR a number with itself, you always get 0. If you XOR two dissimilar numbers, then you get a 1 out. The crucial observation is that for any binary number, if you XOR it with itself, you get 0. Any number. How can you use that? The coolest thing is this is how RAID 5 works. We all know RAID stands for a redundant array of inexpensive disks. RAID 5, the way this works is you have, let's say that you have 4 disks. You give up one of them to redundancy, but then what happens, so you only have the storage of 3 of those disks, but you can kill any of those drives, and you will still have all of your data. How does this magical thing work? XOR. So here is our array. We have 3 disks, A, B, and C. Those are our data drives. And then the 4th drive, I've labeled A, XOR B, XOR C. That's our redundancy drive, in theory. And so the way this works is, if you take, every time you write a byte to A or B or C, the equivalent byte on the redundancy drive contains A, XOR B, XOR C, the equivalent byte, whichever it is. So how does this work? Well, the whole algorithm balances out. Everything settles down to 0, which means that if I take a gun out and shoot A in the head, now we're not contributing the A anymore, so it's not reducing the 1 out, so we get A out. And the same happens for B, and the same happens for C. And if you lose the redundancy drive, well, of course, you're not losing any of your data. You just lost your redundancy, and you can rebuild. The other clever use, if you're building a binary linked list in something low level like, say, C, you can do it with only 1 memory slot. The crucial observation here is that you store what I call a link member instead of a previous. Usually you would store next and previous separately. You store the XOR of those together. Because every time that you're iterating over a doubly linked list, you're starting somewhere like the head or the tail, and you can just remember who the previous one was that you saw. So in order to compute, if you're going, let's say, you're going forward, you would have the link, and you would have the previous one. You XOR those together, and the previous cancels out, and you get the next out. And that works for previous, backwards, and forwards. This makes debugging kind of irritating because you can't just stare at the values anymore. But you can save a lot of memory doing this. And that's it. Thank you.
All right, Joe Shaw, Woven, a Python-powered photo service, is next. And Elliott, pySerial on Raspberry Pi is on deck. And then Chris Felton, Binary Hello World, is in the hole.
The Mac. What the hell just happened? Good? Okay. Yes, ready. All right. These talks have all been pretty interesting. Cool tips and library stuff you may not have heard about. My talk is not going to be like that. It is going to be shamelessly self-serving and self-promotional. I'm here to talk about Woven. It is a photo app and a photo service. You can get it, if there's the URL, you can get it for iOS, Android, Windows Phone, Samsung Smart TVs, all sorts of crazy crap. And the whole thing about it is that we are trying to get your photos from all different kinds of sources. So not only do we upload from your phone or from your computer, so you don't have to worry about if your hard drive crashes or your phone falls in the toilet, but we also pull a lot of photos off of other services like Dropbox, Facebook, and so forth. And I would show you the app, but humanity has not yet invented a way of putting a mobile device up onto a projector, so I can't really show you that, but I can show you sort of well, actually, I'll wait. We've built our app on Flask. We run it under UWSGI and Nginx. We use MongoDB and Redis. We use Pyers, which is a work queue. It's a port of GitHub's Rescue project. We use Elasticsearch for search. Our code base is about 25,000 lines of code and 20,000 lines of tests. We mandate 100% code coverage in our Python, and we follow PEP 8 and PyFlakes. And some of the stuff that the app does. So the aggregation, like I said, so we have to do OAuth, and we have to talk to every crappy API out there in the world. We have to download photos and store them in the cloud and be able to serve them to mobile clients in the right size and try to do that effectively on high latency mobile networks, which is always a lot of fun. We do image processing. We do rotation and size invariant deduplication, so there's a lot of pretty interesting stuff there. We're doing things like event detection and clustering of similar photos. So we look at, you take 10 pictures of your day at the beach, and you want to say that those are all somehow related. So we do clustering and machine learning, that type of stuff. We have people with collections of 50,000 photos, 100,000 photos. We have to figure a way to efficiently send that metadata to your phone, which is not exactly a super fast device. We have to figure out how to send changes and stuff like that, package that effectively. And we have to provide an API for our mobile clients. And we're working on the web app. So I wanted to show you briefly, since I can't show you the actual app, our internal web UI here. This is not meant to be pretty. Okay, pictures of my family. You guys don't care about that stuff. But I do want to show you, there are 3 pictures here of my daughter that look very similar. We don't actually do the deduplication in the internal UI for debugging. But if I click on it here, one neat thing that we do is to detect duplicates, what we do is we take the size of the photo. It doesn't matter if it's 5,000 pixels by 3,000 pixels. We shrink it down to an 8 by 8 pixel thumbnail. We figure out the center of mass of that image, and we can use that to determine whether or not a photo is duplicate. And that actually comes up a lot in our service because we upload from your phone. You probably, as I did here, I shared this photo on Instagram, and it was on my phone, and I shared it into Facebook. So that's 3 copies of the same image. You don't want it showing up. That sucks as a user experience. So here we have this photo. This is the Facebook one. And I have 2 other duplicates here. This is the one that was uploaded off of my phone. And then this is the one that's in Instagram. I'm actually going to show you this code that we do this with as a hope to for you to see what the code looks like. Okay. We take an image from PIL, so we just load the image into PIL. We convert it to sRGB. We drop the alpha channel. We configure the size, the mass. We shrink it down to 8 by 8, and then we rotate it to the right rotation. Okay, yada, yada, yada. I don't have that much time, but I just wanted to show you. This is pretty simple, pretty clean code, and it does some pretty powerful stuff. The last little bit, here's our internal dashboard. It's a different Flask app. We use... this is actually mostly in JavaScript, but we use an app called Cubism. So, okay, I'm running out of time, so enough of that. We've released some open source libraries. RAuth is an OAuth library built on top of Python requests. It's really awesome. You should go to that link to see our projects. Park is a persistent key value store for order transversal keys. Leroy, Jenkins integration with GitHub pull requests and Peep are useful tools for Python development. We're hiring! So email me. All right, thanks.
Okay. Dave Noes, we're moving him to last, just so if anyone, or if Dave, where's Dave? Okay, so you're going to go last, for obvious reasons. Well, you know the reason. So, all right. So next up is Ann Elliott, pySerial on Raspberry Pi. On deck is Chris Felton, Binary Hello World. And in the hole is Eric Welch, Sprint Preview, something. What? Something P Pi. EqPy? Anyway, Sprint Preview.
Oh, great. Okay. They're mirrored. 75? Oh, okay. Change it to 75. One, two. Okay. Let me close. Yes. Okay. All right. I'm ready. So this all starts with, okay, I've got a friend of mine who has a basement. And what happens when it rains? Well, the nearby construction did some really, really dumb things. So when it rains, the basement always floods, so the sub pump has to run like crazy. Guess what else happens when it rains? The power goes out. This is a bit of a problem. So my friend got this whole like cool setup that will eventually have solar panels attached. You got big giant battery bank, battery backup. It charges off the wall power when you've got wall power, and then it goes to float, and then the power goes out, and it auto switches to power the sub pump. This is really, really cool, big fancy thing. And there's this. Well, there's a lot of other issues with that, but we won't go into all of those. It's pretty ridiculous. So then there's this really cool box that does all the data and like handles all the battery charging and makes sure the batteries are healthy. And it outputs tons of data to a serial connector. So picture this. So you've got all your data coming out of serial connector, and you want to keep track of this data. The post box does not track this data on its own at all. So your power goes out. You are running off battery backups, and you are running a laptop trying to keep some sort of computer, trying to keep it up and running off your battery backup that is also preventing your basement from flooding. So Raspberry Pis are the lowest power consumption computer out there, and they can also run off DC, and your batteries are outputting DC power. So the Raspberry Pi is really, really awesome for this. So my friend is like, okay, so we've got... Well, before the Raspberry Pi, he started with his laptop plugged in, and he was watching the data output from this. He says, wow, the graphical interface for this is really ugly. Are you going to write me a better one? I'm like, okay. And then, so he wanted something else, and he also thought, like, that was too expensive, and the Raspberry Pi doesn't run that software because this was under Windows, and it only ran under Windows. I'm like, it only runs under Windows. What? So he said, well, okay, so the documentation comes with, it's just outputting text over a serial port. That should be easy, right? I'm like, I don't do hardware. And so then I read the documentation, and then I found out you can import pySerial and get strings. So, from all that scary stuff, what I ended up doing is I wrote this surprisingly long piece of code, actually. So import sys, the first thing I do is I have a PID file check because security, only one thing can attach to the dev port at once, and /dev where the serial port is. So then, look, import serial. I don't have to know anything about hardware. And then this is all like really fancy important stuff that the documentation told me what to type in. Then I have, let's just output it to wherever you run this code from. Our output file will have a tab separation. And so then there's like all these stupid names in the output text. So I have a nice little dictionary that tells me fancy names to use. There's a couple categories we really don't care about, so we ignore those. And then there's some things you want to multiply or divide by 1,000 for fancy units and stuff like that, so write those down. Hey, look, let's connect to the hardware. Serial.serial, all that information I already typed in. Ta-da! I'm talking to hardware. And so then I make an output file, and I have something set up where it rotates log files every day at like 10 a.m. It'll start a new file, so you can check day by day. And then every time it opens a new file, it writes out the headers for you. And then you've got to get dates. Oh, yeah, you figure out if you want to make a new file or not. So then tons of setup, blah, blah, blah. And so then, okay, so serial, give me a line. Lines are cool. And if it starts with V, we've got a new one. We'll find a new timestamp, so we'll start a new line in the CSV file. We make a fancy dictionary. We get it ordered dictionary so we don't screw up anything because it's, a CSV file. And then you write out the CSV file, blah, blah, blah. And that's all you need to know in order to use serial. So then you get an output like this. Whee! Look, I have a tab separated value. It's big giant file with headers at the top somewhere. Okay, there we go. Look, I got headers too.
Okay, the binary hello world. We all find the hello world program compelling. I believe, right? Or at least we find ourselves compelled to write one if we're learning a new language or if we're showing someone a new language. In Python, it's pretty easy, right? We can pop open the interpreter, type in print hello world or whatever string we might want to type in. But it's easy. It gives us some confidence. It's a baby step. We can move on from there. Now, some systems, we don't have a display to print out the text on. So this interesting little hat I'm wearing, a propeller beanie hat, has a microcontroller in it. And this microcontroller you can actually program with Python. But if I want to do my kind of baby step, my hello world program, I can't display to a screen. There is no screen on this. So usually what we do if we have kind of an embedded system type hardware, we'll blink an LED. So our binary hello world is just simply blinking an LED. So this microcontroller actually has a version of the Python virtual machine, and it executes the bytecode. And another set of hardware I have here that's blinking an LED is actually a field programmable gate array. So this hardware does not execute instructions. It's actual programmable hardware. You tell the hardware how to define its circuit. I think I'm falling about here. Now in this, we have the same thing. I don't have a display in here. I'm not going to write out a print hello world. So what I'm going to do is I'm going to blink an LED. So in these type of custom hardware, embedded system type hardware, our hello world is a blinky LED. All right, so why am I talking about this? Part of it, thank you. So why am I talking about this? Part of it is, there's hardware out there that can actually have these embedded Python virtual machines, but I'm also giving a talk tomorrow on a Python package called myHDL. myHDL allows you to write digital circuit behavioral descriptions in Python. And so that's what I did right here. So I was able to describe the circuit that would blink this LED. So you can write your hello world programs for digital circuits in Python. So also tomorrow at the end of the day, we're going to do a little hands-on workshop. So I have a whole bunch of these boards. We're going to sit down and you can program your own little hello world and modify the hello world and see what it feels like to kind of program some digital hardware. I can show you some code quickly here. So I have some time. Is that readable? Yes. Better? Bigger. Whoa, too big. Okay. So here we have a function. We use kind of hardware description. We'll call this a module. It kind of overloads with the Python module, but it's just other people that use other HDLs are used to calling it a module, so we often call it a module. We have a bunch of stuff just to set up a bunch of parameters what our hardware will be. And then here is kind of the meat of the code. We actually can define the description of the hardware circuit. But I'll talk more about this tomorrow in a talk, so if it seems interesting, come join. All right, thank you.
All right. Eric Welch, Sprint Preview, is next. On deck is Brad Montgomery, What I Did During Julython. And then in the hole is Dave Noyes. Noyes? Okay.
Okay. I'll be sprinting tonight on a new project. And by new project, I mean it was a short, quick hack I did yesterday. And it's I'm going to turn into like 33 slides, so I'll be quick. It's called EqPy. It's managing systems of equations easily, and simply. It's Python. That's what we want. And by system of equation, this is what I mean, like x equals 2, and so on. That's blinding, Jim. And so let's go with that. Here we have the two inputs. We define a system, A equals system, and we can choose, let me get the mouse out of the way. X equals 2, Y equals A.x, which we haven't defined yet, but we can use it. and then boom, we solve it, and the solve returns a dictionary. But we can also look at the object itself, and boom, boom, this is the input equations, and that's the output equations. And we can do a lot more, but first, yes, some history. It began yesterday, so it's a day old. And it's been way longer working on this talk than the actual script. So it's just born. It's a proof of concept, the code. It will change a lot, and I welcome input, feedback. I think we design what it could or should do. I have a lot of ideas of what it can do. So please join. And the way this came about is there's a colleague who he does Python but doesn't know some Py or Pandas and was solving some different systems that are interrelated, and this was to make it easy for him. And the data has data, so we annotate the data with more data, and I'll talk more about that later. And the solutions, we want to actually be able to handle it in a flexible and powerful way. So, which once you have this solution, we can export to Pandas data frame. All right, so let's continue. And we can make the API and syntax simpler than what it is now. It's a proof of concept. So symbolic solution. So if you mistype something or if you don't know what something is, here we have x equals a dot z. We didn't define z anywhere, so we solve it, and the solutions are in terms of z. So x equals z plus 2, y equals z plus 4. And that looks easy to me. Hopefully people agree. And it doesn't have to be linear. It can be just any system of equations, and hopefully it's solvable. And if you can't do it symbolically, hopefully you can do it numerically. And here we see it's all that just fine. And in the real world, you don't have x1, x2, x3, or xyz. You have different systems, and these systems are interdependent and have relationships. And sometimes you want to exchange out different inputs. And so let's define a new system B, and then A references B.z, and we set z equals 4. And we solve that collection of groups, the input equations for A we see, and these solutions are shown there. Boom. Now, if we want a different B, it's called B2. We use z equals 2. So we solve it with B2 instead, and we get a different solutions. Halfway through a minute ago, namespaces are shared, and so sometimes you make a namespace with the prefix or suffix, boom, 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 and the outputs. Okay, and sometimes your data has data. We can set things for attributes, and let's make a basic equations and solve it. This is. We have the inputs, outputs, attributes. All right, we solved it. Great. Now let's use it, export to a frame. There's the x, y, z. Solutions, attributes. And it's pandas. We can mess with things. So let's sort this by solutions. Let's say it's time or something. And we make a plot. Now, this was whipped up, so the plot's not too interesting, but proof of concept, it's handy, I think. And brother sprint, needs everything. You can make me help. You can join. Boom.
Up is Eric Welch. Or no. Up is Brad Montgomery, what I did during Julython. And Dave, you're on deck.
Yes. Hello. My name is Brad. Okay. What? For the record, it didn't let me choose that on the other machine. We're good? Yes, go. So my name is Brad. How many of you know what Julython is? All right. How many of you participated this year? Oh, yes. Why? Okay, so let's have that conversation later. But if you don't know, Julython is an opportunity to do Python programming for the entire month of July. It's, what could be more fun? It's a chance to do a side project or some open source stuff or whatever, as long as it's Python, and it's kind of a game, so you could check it out, julython.com, I think, maybe .org. But you get internet points, which are always awesome. So next question. How many of you know what this is? All right. So what is it? Yeah, GitHub contribution growth. So what do the little blocks mean? So there's some different colors, right? What are the good colors here? Dark green is good, right? What's bad? White, right. So this is my GitHub contribution graph, and I look at this and I'm like, yeah, I'm like making some awesome progress. And then I log out of GitHub and look at it again, which means it only shows my private stuff when I'm logged in. So this is actually my public stuff. Oh, like this is kind of a kick, right? So I would kind of like to fix this. I want to be a good community member. So my goal for Julython was contribute to something open source every single day in July. Okay, cool. Sounds like a nice goal. And sneak peek at the end of the story here. This is what I accomplished. But there was a problem. I'm not actually doing anything really useful. So I had to stop and think, what am I going to do? Right, I do have some open source stuff, right? This is one of my more popular projects. So the 5 is really close to the T, and I kept hitting 5 instead of T. So like I can put comments in my templates without. Anyways, right. No, so I want to do something that's actually somewhat useful. So what can I do? And people like to write real code that actually does things, right? But tests, I don't. Maybe there's an opportunity here. So I started looking, and but good intentions, and end of the day, maybe I don't always get a chance to contribute things that I want. So I end up doing stuff like this. It's a commit, right? Goal achieved, right? No, and that went over as well as I hoped. So, no, really. So some days, I had stuff like this, right? I committed a test, right? And I'm thinking, yeah, I kind of feel like a slacker, but if we all spent every single day for an entire month committing a test to a project that we use, or even a side project that we have, we'd probably have some pretty awesomely tested stuff. So this is what I ended up with. I fell a little bit short of my goal. I did have a 26-day long streak where I committed to open source stuff. Unfortunately, most of that was my own code. Next year, I'm going to commit to other people's code. There's one problem, though. There's a couple of days here I goofed. In fact, I got so excited about PyOhio driving up here, and then today, or yesterday actually, I forgot to do anything. So I'm going to have to start all over and do this the entire month of August, and there's not a August-lython, but, if you guys are interested, join me, and we can... all that untested code out there, we take care of it. So, if not next month, next year, join me for July tests. Thank you.